All right, so let's check out the derivatives of natural log. Yesterday we talked about the derivatives of e's, and e to the x and a to the x. And so today we're going to deal with the logs. And remember that logs and exponents are inverses of each other. So if you have log base a, this remember is your base. So it's a to the y is equal to x. And so let's derive the derivative of natural log of u, where u is some function of x. Obviously, it's not just going to always be a sweet little x. It's going to be the natural log of x squared plus 5 or something, the natural log of cosine of x. So u is some function of x. So we're trying to figure out the derivative of this thing with respect to x. So by what we just talked about, if we know y equals ln of u, then my base is e, so e to the y would be equal to u. Now let's use implicit to figure out the derivative of that. So that would be on the left, from what we learned yesterday, e to the y, copy, times the derivative of the exponent is equal to, now I'm going to write this in a certain way. It would be the derivative of u with respect to x. So I'm going to put u prime for the sake of what we're going to do. It's also du dx. And then what am I going to do? I'm going to try to solve for dy dx. So I'm going to divide by e to the y. So I have e to the y. But looking back up at the beginning, notice what I have, that e to the y is equal to u. So dy dx, and this is why I like to write it as u prime, because it's easy for me to memorize and say, dy dx is u prime over u. And that's going to be the formula that you're going to memorize for natural logs. So very simply, if y is equal to ln of x, then dy dx, if this is simply just x, well, that's our u. It goes on bottom. What's the derivative of x? Is 1. So dy dx is 1 over x. And then we got to throw in some absolute values. We love absolute values, right? And what have we done every time? Because we know we can't take the derivatives of absolute values. So every time we said, well, okay, we have to write this function without the absolute value. So remember the steps in doing that. If x is already greater than 0, now notice I don't put equal to, because remember that the domain of logs is you can't take the log of a negative number, can't take the log of 0, or negative numbers for that matter. But with the absolute value, the only thing that's troubling me is 0 itself. So if x is already positive, those absolute values aren't doing anything, and my function would just be natural log of x. But if x were less than 0, like -2, then of course that absolute value would change the sign, so I could write that as the natural log of -x. Now by what we just talked about, let's find the derivative. Let's find dy dx for both of those. Well, the top one is what we just did. So if x is positive, the derivative is going to be 1 over x, because that's what we did right over here. Let's look at if x is less than 0. So what happens if we have natural log of -x? So this would be our u. It goes on the bottom, so -x. Now what is the derivative of -x? That's -1. What does that turn out to be? Well, very nicely, those cancel, and I also get 1 over x. So you're like, okay. The good news is, friends, for once, an absolute value, if you see an absolute value in a problem like this, you can literally ignore it. So that's the beauty of natural logs when you see the absolute value. You can, even if there are absolute values right here, you can totally ignore the absolute values when taking the derivative of a natural log. That's all I'm talking about. If you're taking the derivative and you have a natural log, then even if the argument has an absolute value around it, you totally pretend like it's a parentheses, you totally ignore it. It has no effect and bearing on your answer. So here's what it comes down to. You are going to memorize that the derivative of the natural log of u is u prime over u. Once again, like we said yesterday, this unit is very formula based. If you have the formulas memorized, it's very simple. If you don't have those memorized, you're going to get a lot of points off. So let's get them memorized. And notice that the questions don't take very long if you have them memorized. So when it says differentiate, y equals natural log of x cubed plus 1, you pretty much go straight to the answer. And I do it in this order. I know it's u prime over u, where this guy is my u. So I tend to put that on the bottom first. So I just copy that, and then I ask myself, well, what goes on top is u prime, the derivative of that. So I look at that denominator and I say, what's the derivative of that? And you go 3x squared, and that problem is over. That's it. Example 3, do those absolute values bother me? Nope. I'm taking the derivative of a log. So even though it's absolute value, I just pretend like it's parentheses. I literally ignore that absolute value. And dy dx, by the same token, here's my u. I would put sine on bottom. What's the derivative of sine? Is, of course, cosine. And I would pretty much bet if they were putting this on multiple choice, got to throw a little trig identity in there when it's so obvious like that. What is cosine over sine? And that is cotangent. Notice I do not have absolute values. If I were writing a test, then I would put absolute values around cotangent as a wrong answer. Absolute value in the question, you literally ignore it. And what I'm saying is this is the correct answer, but you might see an answer like this, and you certainly would not want to pick that. So it is not an absolute value in the question. For derivatives of natural logs, you for once can literally ignore it. All right, let's look at the next one. Okay, so what's going on back here? First of all, I want to look at number 4 and make sure we understand what that's saying. Let's rewrite that in another way. If I rewrote y equals, I think you would agree that that's the natural log of x to the 1/2 power. All of that's being raised to the first power. So I want to be very clear that the natural log, these two things, sorry, I don't know, the pen is being weird. Natural log of x to the 1/2 is not the same thing without those parentheses, because here what's being raised to the 1/2 is the natural log of x, whereas here what's being raised to the 1/2 is just the x. So make sure that you know the difference between the two of those. So let's do the one on the left. If I write it as a power, what must I remember when doing the power rule? You've got to, as we've said, when you're doing the power rule with parentheses, man, you better be thinking of the chain rule. So let's think of our words. We're going to do power to the front, decrease the power by 1, but I can't stop there, times the inner derivative. So times the derivative of ln of x. Okay, the derivative of ln of x, that one you just need to memorize. I mean, yes, it's u prime over u, but that's a very simple one. It's 1 over x. Now let's write that in the way they would probably type it in, a multiple choice. All that stuff is in the denominator, so you have 1. You are multiplying, so they'd probably group the 2 and the x together, and then they'd probably stick that natural log underneath a square root. Now, just for the sake of making sure we understand, let's look at this one on the right, and let's remember a few things. If I wanted to take, I know it's not on your paper, but if I wanted to take the derivative of that thing, I certainly could consider this to be my u and take the derivative of u, do u prime over u, and get that. But watch a smart idea. Do you remember log properties? There were 3 log properties that we discussed at the beginning of the year, and you did all last year in pre-cal. And one of them was if I have a power like this on the argument, do you remember how I can move that to the front? So I could rewrite this guy as 1/2 natural log of x. And if I do it that way, oh gosh, the derivative is so much easier because I have dy dx, just like I have a constant, like the 1/2 kind of comes along for the ride. And then the derivative of natural log of x is 1 over x. So I get dy dx is 1 over 2x. That is much faster than trying to do the derivative of him. I would get negative exponents. I'll get the right answer, but there's probably more room for error. So that idea of using log properties is a really, really good idea. Let's look at example 5 and we'll see how it makes that so easy, or much easier, I guess. Because again, did the absolute values bother me? No, I'm totally ignoring those. But are you telling me if you were doing u prime over u, when I went to do u prime, I'd have to do the quotient rule, I've got a square root, it would get so tremendously ugly. Let's consider going, you know what, let's use log properties. I'm just going to change that to parentheses. So what were the log properties that you have to remember? Well, we talked about the power to the front. The other ones were the log, obviously with the same base. So I'm saying log. I'll go ahead and put ln. As long as you have the same base, they're all the same. The log of, if you have a times b, you can add the individual logs. And if you divide a over b, then you subtract the logs. So looking at number 5, with those in mind, I could rewrite this way. So notice I'm not taking the derivative yet. I'm saying that's the natural log of x minus 1, that's on top, minus the natural log of x minus 2. Now that would be x minus 2 to the 1/2. So I'm going to combine it with the property we discussed up here, and I could rewrite it that way. Now go down the line and take the individual derivatives. So dy dx, if I were doing this guy, of course this is my u, so the derivative would be x minus 1. What's the derivative of x minus 1? Just 1, so he goes on top. I have a minus. Once again, the 2 comes along for the ride. And I would have x minus 2 because this is my u. And the derivative of x minus 2 is just 1. And then look at your answer blanks, because they might leave it like this, but my guess is on this one it's so simple that they wouldn't. They might get a common denominator, but I promise you the work in doing that is much shorter than the work of, again, doing the u prime over u with that real complicated value of u. So let me get this with one denominator, or with a common denominator. I know it's going to be a 2 times x minus 2 times x minus 1. So I think to myself what each of these guys need. I'm going to put it right here. This guy would need an x minus 1. So I'd have to multiply by an x minus 1 on top. This guy, if I can, I'll move this dy dx over a smidge so I can have room. Dy dx. This guy will need a 2x minus 2. So I have to do that on top and bottom. So once I have that common denominator, think about what I have. I would have 2x minus 4, because I'm distributing this. Be careful, very easy to miss a sign right here. I have a minus x minus 1, so that's minus x plus 1. So what does that leave me? My final answer, so dy dx, is going to be x minus 3 over 2 times x minus 2 and x minus 1. Again, if they multiply out that denominator, you certainly could do that, but there you go. All right, why don't you try number 6 with this understanding? Let's say this is on multiple choice, but they do not get a common denominator. You have 3, they stop in this step right here. They do not get a common denominator. So stop the video, see if you can get this one. Well, I hope that you certainly use log properties. There is no way you want to do this guy. Find the derivative of that. That'd be impossible, nearly. So let's use our log properties. I would have the natural log of x, because he's on top, plus 2 natural log of x squared plus 1 minus the natural log of 2x cubed minus 1. That would be to the 1/2, so that 1/2 is right there. So again, what I did there, I wasn't doing the derivative, I was just rewriting using log properties, rewriting the original. So I'm now going to go down the line, which each of these 3 things, and find the derivative of each thing. So the derivative of ln of x is 1 over x plus this 2 is going to be on top. My u is x squared plus 1. And then I multiply by the derivative on top, which would be 2x minus, again, you have the half on the bottom. I have 2x cubed minus 1. The derivative of that would be 6x squared. And I said that they did not get a common denominator, but they certainly would clean things up. So we have dy dx is equal to 1 over x plus 4x over x squared plus 1 minus, let's see, 2, 3, so 3x squared over 2x cubed minus 1. Looks good. And that's going to be my answer. So those log properties. When do you do log properties? When your u is very, very difficult. When your u is tough, that's when you kind of need to think of log properties. All right, last one. So I'm finding the derivative again. Like we talked about, we're just infusing the new material with the old. So I see a product. So I need to remember to do the product rule. So I have first and second. So dy dx is going to be the first times the derivative of the second, u prime over u, so 2x there, a 2 on the top, plus the second, ln of 2x, times the derivative of the first. That's what we did yesterday, so it's copy times the derivative of the exponent, so that would be 3. And again, just a little reducing there. dy dx, those 2's cancel. So e to the 3x over x plus, not a whole lot I can do here. I might put the 3 in front. again, those are multiplied, so they can be in any order. So however you put that is fine. And there you have it. So that is how you take derivatives of logs. Peace out.